Okay, in this video, I want to talk about part of homework number 15, which is this one, the extra review problems for chapter 3. So please feel free to open up the link so you can view those 3 problems, but this is part of your homework number 15 that you will submit together. Okay, and I'll give you a little bit of guidance on those problems. And you're going to solve them algebraically and graphically. For the graph, please remember to label your solutions on the graph clearly. And I'm going to show you how to do that with some of the guidance in this problem. So number 1, let's first solve this equation algebraically. So first thing, what I see there is whenever you're solving an absolute value function, you want to have the absolute value alone. So I'm going to get rid of the 4 by dividing by 4 both sides. So then absolute value of x minus 2 is equal to 3. And then here we can use what we reviewed, the looking inside method, where we're looking inside the absolute value. When we think about it, what number inside the absolute value will give us a positive 3 out? And that number can be both positive 3, because absolute value of 3 is positive 3, or absolute value of negative 3, because absolute value of negative 3 is also positive 3. So hopefully you can see that inside the absolute value can be both 3 or negative 3, which means this can equal to both positive 3, because then we give absolute value of 3 is 3, or x minus 2 can also equal to negative 3, because if this was negative 3, absolute value of negative 3 is also positive 3. So we start with 2 equations from the absolute value. This is usually the step that we follow. Absolute value equation expands and leads to 2 equations. So again, we have x equals 5 and x equals negative 1. But just in case we have any extraneous solution, we want to check this. So let's check x equals 5 first. 4 times 5 minus 2, does that equal to 12? And looks like it is. So x equals 5 is a solution. Let's check negative 1. Plug it into the equation. 4 times negative 1 minus 2. Does that equal to 12? Does this make the equation true? That's 4 times absolute value of negative 3, which makes it positive 3. And looks like that is also true. So x equals negative 1 is my second solution. As for the graph, there are 2 ways. So I'm going to call this method number 1. We're starting with the original equation. What you can do is graph the equation on the left. So I'm going to call this y1 and graph the right side of the equation. So I'm going to graph 4 times absolute value of x minus 2, and I'm going to graph y equals 12. We graph each of these functions separately, but then find where they intersect, because they're set equal to each other. So find where they intersect, and the x value will be our solution. So let's graph this. So here I labeled my axes. I made it big enough because I need to go all the way to 12. Let's start with the first equation. This is an absolute value equation with locator point at 2, 0. So I'll put a point there, locator point. And then a value behaves like a slope. So I'm going to go up 4 and right 1. So 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. Then on the other side of up 4, left 1. Symmetric, so just label your points, then draw your graph. And I'm going to label this graph as y sub 1. So that's my first equation. And then the second equation is y equals 12. So where's the y value equal to 12? It's right here. So we're now going to draw a horizontal line at y equals 12. And that's my second graph. And then this is the important part. You need to find where they intersect. They intersect at this point and this point. The points of intersection, if I label it, it's 5, 12 and -1, 12. But this is a key. Look at the original problem. What's the variable in your equation? The variable that exists in your equation is x, only x. Therefore, don't give me the points. I want you to just give me the x value of your solution. So then, what is the x value of this point? It's where x equals -1. That's my first solution. Second point of intersection is 5, 12. That's the point coordinate, but I only want the x value of the point, which is 5. That's my second solution. And again, that's because my original equation only has x in the equation. This is what I was asked to solve, and it only has an x. Therefore, my solution only should be the x coordinates. Now let me show you the second method. I'm still solving the same equation, but I'm showing you how to do it graphically with another method. And this is actually what I would do. So first thing, you start with the original equation. It's the original same equation, but instead of graphing the left and right, which is what I did on the first method, I graphed the left side and the right side and graphed it together. What I'm going to do is I'm going to reduce it by dividing them both by 4. Then I get absolute value of x minus 2 equals 3. And I'm going to graph the left side of this equation and the right side of this equation. So I'm going to graph absolute value of x minus 2 and absolute value of 3. This is basically the version of graphing the reduced equation. I guess that's the way to call it. Because this one takes so much space. You need to go all the way to positive 12. And I don't want to make a big graph. So I want to make a smaller graph by graphing this. So this time, first absolute value has a locator point at 2, 0. So 2, 0 is what I will start with. And then it looks like it has a slope of 1. There's no particular a value, so it's just 1, which means I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. And just draw my line. Same thing on the other side, up left 1. And draw my graph. I'm done with absolute value. The second one is 3, y equals 3. That's a horizontal line going through y value of 3. So I'm going to draw the line here. Same thing, find where they intersect. But then my original equation has only x in the equation, right? My original equation only has an x. So then looking at where they intersect, I know that the coordinate here is 5, 3 and -1, 3, but I only care about the x coordinate because my original equation only has an x. So then we're going to say this is x value of 5. And then this is an x value of -1. And those are my solutions. Exactly same as my previous graph. And then my algebra. Number 2, to solve it algebraically, isolate the square root function. Before, we isolated only the absolute value by dividing 4 both sides. Now we're going to isolate the square root by subtracting 8 both sides first. You always want to isolate them, leave them alone. You shouldn't have anything else around it. Absolute value of x minus 2 is x minus 8. Then now you can undo the square root by squaring both sides. Then we have x minus 2 equals x minus 8 squared, which I'm going to ask you to expand by multiplying it out, x minus 8 times x minus 8. So once you do that, you should get x squared minus 16x plus 64. Please make sure you know how to do this, not just from copying me. You want to be able to do this on your own. So then move everything to one side to make this equal to 0. Subtract x, add 2 both sides, you get x squared minus 17x plus 66. And this is going to be factorable. It's going to be x minus 11 and minus 6. So you get x equals positive 11 and positive 6. But just in case this is a square root function, we're going to check for extraneous solution. Check 11. So let's plug it in here. Square root of 11 minus 2 plus 8. Does that equal to 11? Let's see. Square root of 9 is a 3. And it looks like that is true. X equals 11 is a solution. Let's check 6. Check x equals 6. Plug it back in. See if it makes the equation true. 6 minus 2 square root plus 8. Does that equal to 6? 4. That's a 2. And uh-oh, I get 10 on the left side, which is not equal to 6, and that means x equals 6 is an extraneous solution. It's not really the true solution of this equation. It's a fake solution. But you still want to state that it's extraneous. So once you have done the algebra part, and again, you want to be able to do this for any types of other problems. So don't just copy this. I need you to give it a try first. The graphing method. There are 2 graphing methods as well. So if you look at my previous video with the first problem, you'll know this. The first method is to graph the left side function and the right side separately. So I'm going to call it left and right. I'm going to graph this left side and the right side and see where they cross. So first one, then I'm going to be graphing this side as my first equation, and then I will graph the right side, which is just equal to x. These 2 are the ones that I'm going to be graphing. Okay, so let's start with the first one. This is square root of x minus 2 plus 8. So did you find the locator point? Did you graph the locator point at 2, 8? That's the first thing. And then you can make a table of values, 2a. You already know what the square root graph looked like. You should know it. It looks like this. So my graph is going this way, which means I can plug in a 3. And that's going to be a 9. So 3, 9. You can plug in, can you do a 4? No, 4 wouldn't work because 4 minus 2 is a 2 and you can't square root 2. We can do 11 because 11 minus 2 is 9. Square root of 9 is 3 plus 8 is going to be 11. So 11. Right here, draw my graph. That's my first one. Second one is a linear graph. So then it's just going to be y-intercept 0 and go up 1, right 1. It's the slope of 1. It's just y equals x. So your slope is just 1. Draw those dots, connect the points. And it looks like it is intersecting at one particular point at 11, 11. I'm going to circle it. But again, my original equation has x, only has x. So my answer should only have x coordinate. So again, double check the x coordinate of my graph solution is 11, which is exactly same as the real answer I got over here. X equals 11. That's method number 1. Method number 2 is by reducing the equation or rewriting it. What I'm going to do is I'm just going to move over the 8. So then on the left side, I have square root of x minus 2. On the right side, I have x minus 8. And I'm going to graph this one and this one. I'm going to graph square root of x minus 2 and graph x minus 8. Okay, so graph those two functions, find where they intersect, and figure out the x-coordinate of your point. The next part I'm going to talk about is just briefly number 3. Same thing, solve this algebraically first, and then you're going to solve it graphically, but now it's going to be up to you. Are you going to be graphing the left side and the right side? Or are you going to be rewriting this graph by reducing it and graph the left and right side of the reduced graph? That's going to be up to you, but I want you to give it a try and see if you get the correct answer for number 3 as well. And if you're trying the second method for the graph, please check the answer key afterwards.